All right, everyone. Pleasant good evening. Good evening, everyone.
Good evening, sir.
Good evening.
Good evening.
Evening, everybody.
Good
All right.
evening.
Hi, Zahina. How are you? All right. All right. So we have 19 persons in attendance. All right. So I think Sashmanik and Levon Hans, I think you're writing on the screen. I'm not sure. Okay. Gotcha. All right. Ladies and gentlemen. All right. So I want to take a little moment, maybe about 3 or so minutes. I'm gonna start the class a little bit different, right? And I'm the type of person that is very motivating, inspiring, and I try to always motivate my students. Not just about my subject that I teach, but life lessons. There are some of you here that are younger than I am. And there might be a few persons here that are older than I am. Regardless, lessons don't come from just persons who are older, but you can always learn from persons who are younger and persons who have been in situations that you may not have been in as yet, right? Or you may never get yourself into. So what I want to share with you is the importance of or to understand that we, we basically in a system that's designed to pretty much keep you at a particular level, right? And that particular level, um, one of the biggest pothole that a lot of you guys will fall into is the pothole where it's very difficult for you to get to the next level if you don't, say, for example, pass your subjects, right? Then put mathematics on the epitome. But if you don't pass your subjects, you can't get the next job, which we all know that majority of the time, whatever we learn in school usually doesn't apply in the real life. Well, some of it does, but not all of it. Life is a very unfair situation. And what I'm about to share with you is it could never be more true. Them have a saying in Jamaica where them say, wanty, don't get it, and get it, don't want it. And something that I saw this evening that really, it kind of just make me know say a lot of us who have the desire, have the push, have the drive to do certain things, we are not in a position where we're given the opportunity, and sometimes we have to either make it or we have to take shortcut. So one of my students came to class this evening at about minutes to 4. And when the student came to class, the student came with a SB showing me the questionnaire. So immediately, because I've been observing the student for weeks and months, right? The student goes to a prominent high school, which I cannot name, because maybe by the time I start telling the story, y'all put one and two together and figure out whom you talk. So the student goes to a prominent high school here in Mandeville. And the student brought an SBA to me. So my response was, now that we get the chance to address him, my response to the student was, if you complete this SBA by whatever means necessary and you end up with a good grade, the approach towards the coursework and going into that exam and not doing anything, you would have defeated the purpose of all the efforts you're putting into the SBA. You have a lot of students who they know that if they don't do an SBA, they don't have a chance to pass. So what they do is that they hurry up and get an SBA done by whatever means necessary, and still they are not equipped at the coursework. Hence, therefore, when they go into the exam, what is on the paper they cannot deliver. So they have a very good SBA, which obviously means that it could have been AI'd or somebody could have given them an SBA and them edit it. So several things can happen why somebody can get a good SBA grade. A good SBA doesn't guarantee you a pass. It just guarantees that you're going to get a grade. You just don't know what grade it's going to be. Skipping all of that to say this, I said to the student that if you complete this SBA and you get a good grade, And based on your performance over the past at both at your school and here at this institution, it looks very likely that you're going to undermine your own efforts. He said, yes, sir, I understand, and left it at that. I went into the class to teach, and I am so, whenever the students are in front of me, I can only pay attention to who is in front of me. And I'm not always going to be aware of who is supposed to be in the class. It's just sometimes I'll be like, oh, where's Miss Gentles, or where's Sash Monique, or, it will pop up in my head. I was about leaving the school this evening when a parent came into the office and said to me, Mr. Peart, sorry, are you the math teacher? I said, yes, I am. He said, have you seen X and Y? I said, no, they were here earlier discussing something with the SBA. He said, I haven't seen them. Then he looked through the window and he looked across the building. He saw the two individuals across the road. I'm not sure what they were doing. Mind you, they're young, so they're still immature in their mind. But when I observed, what I saw was that it was a it was a white it was a gentleman that was, it's safe to say that the gentleman is a Jamaican, but them white Jamaican people, a rich background, right? And the car that him drive, obviously you can see that the person is well off. And what I saw was that when the young man came to me, he came to the office and this was what he said. He said to me, Mr. Peart, what topic did you teach? No, I was reluctant to answer because it's really a question that did not deserve an answer, because I'm not sure why you're asking me that. You were supposed to be in class to know what that is. The student asked me what topic I teach. I told the student that I taught X topic. His response to I think it's the grandfather. I'm not sure if it's the father. It could be, but I'm gonna assume it's the grandfather. I'm gonna assume it's the father, but a big man, like in 50s, 60s, maybe. His response to the father was, "Oh, I can watch the video," knowing well that this child is not going to watch the video, because if I took up my money and I pay your school fees to come to a class for you to get extra help, and when you come to the class, you're telling me now that you're going to watch a video to catch up, knowing well that you're not going to do it. So what I observe is that this particular parent is well off. Them have the money to send the child come school, but the child is not taking advantage of that, because the child obviously know that the parents might be well off. There might be other opportunities other than going to school and taking advantage of the help that is being given. And there are persons who genuinely do not have it and have to pay the school fee and come here. So the point I'm trying to make, ladies and gentlemen, boys and girls, is life is very unfair, because you may be one of those persons who find it very difficult to pay the school fees every 3 months, and you're trying so hard, and yet life is dealing you a hand, while others out there who pretty much can just pay it with them eyes closed and it doesn't affect them, and they are not making very good use of it. Ladies and gentlemen, life is bigger than just having or just coming into a classroom or coming online and sitting down and learning about X and Y, A and B, P and Q. There's life out there to live, and there's good jobs and careers for you to chase down. But if you continue to make decisions such as, coming to class when you feel like, or learning if you feel like, or studying when you feel like, you're going to find yourself stuck at this level where you're constantly making the same excuse, or you're doing the same thing expecting a different result. So it's very important that when you get an opportunity, right, which is sometimes very rare, and I'm not putting myself on a pedestal, but I give my students 110%. Every day I have a high school student that comes to me to say, "Sir, if it's not your class, I don't know how I'm going to manage." And I'm giving you all 100%. I expect that when I want in a day or so for 2 years, 3 years, I try pass one subject that really doesn't require, it's challenging, but it doesn't require a lot. It does require some level of dedication and discipline and consistency, but it's not impossible. It's very doable. But if you guys continue and continue, quite a few of you, maybe not in here, but if you are demonstrating the skill set of students who are inconsistent, practice when you want, study when you want, and this goes for all subjects, you'll find yourself coming to an institution like Manchester Institute having to do the same thing over and over, paying more and more money every year, trying to get one result. So I urge you and I implore you that whenever you get an opportunity to try to level up, try to use as much of the resources that is available for you online. It is full time that you guys get a chance, pass the subject, get it out of your way, so that you can come out of this matrix and go into the next one. Because understand, very importantly, the system, unless you're planning to start a business, or I don't know what you guys are planning to do, but unless you plan to cheat the system and decides, you know what, I'm gonna make it out of life without having to get up the subjects required with them some need, you guys are gonna be stuck at this level. And you're not going to stop. They know it's your weakness, so what they do, they implant it in every career choice that you make. So no matter what you think you're going to take on, whether a career or a job, the Chinese persons that are owning the restaurants are asking. They are asking for mathematics and English. Not sure why, but they're asking for it. They know that's what's hindering you, and they know exactly that if you do not have it, they have the option of underpaying you. So we need to quickly get this thing out of the way so we can move on with the life, buy some good cars, buy a house, and get rich, as now always say, and move on. But this thing named mathematics is going to hinder a lot of us. And I'm here because I was chosen to help you guys to pass this stage. Don't take it for granted, right? I understand that you don't really know why you're doing a lot of these things because you're not applying in real life, but the system is designed that way. It's not designed based on teaching you what you need to learn to earn money. It's designed in such a way that they put the most challenging obstacles in front of you so that they can keep you here for as long as possible and drain you, drain your pocket, drain your energy so that you can stay here. And then by the time you get through, many opportunities would have passed you by because you lack the consistency and determination. All right, so that's my motivation to you. I don't know if that might have touched some nerves here in this class, but if it has, try your very best, guys. Do not stagger in this lane down here because down here, so I see and I know what the problem is, but many persons they usually just don't listen or they just choose to hear what they want to hear. So wrap it up, people. It's not impossible. You can do this, but it requires discipline and consistency, and you have to do it even when you don't feel like you want to do it. Okay? All right. So that's my motivation. Hopefully that may have, you know, um, may
Thank
have,
you, Sarah.
yeah, you're most welcome. So hopefully that helps some of you guys in terms of your attitude towards, getting this subject. Your success is my success, guys. So yes, when you're successful, I am successful. If you're unsuccessful, I am unsuccessful. No matter if I get 10 pass out of 100, 10 pass out of 100 is still a failure. All right? So let us, put hands and hearts and focus together and get this thing done. All right? My apologies for taking so much time out of your class. So let's jump right into objective for tonight. Okay? All right. So tonight is Monday. Zahine, what we're doing tonight?
Sir, I'm not sure.
Hmm?
Sir,
Yeah.
I'm not sure.
I know that we're supposed to be on I think it's transformation that we're doing, right? Or is it on a Wednesday?
No, sir. We stopped at linear equations.
Okay, all right, good. I remember now. Thank you so much. All right, linear equations. So we're gonna use the next 6 minutes now and tie it up at 7:30, and so we can move on to quadratic equations tonight. Okay, so that's the objective. All right. All right, good. So last week, all right. Anybody has any questions? Any comments? Anything? I saw your clap, Tajan. Thank you for appreciate. Yeah. All right, no questions. Comments? Okay. All right, good. All right, so last week we would have been exposed to how to solve equations, which is crucial to the topics coming up. Equations is just something that you're going to be using all the time, right? It's the heartbeat of everything that you do in mathematics. Everything, graphing has equations, matrices have equations, functions, relations have equations, trigonometry has equations, geometry, everything has equation. So the importance of understanding how to solve these equations. So let's look at a few examples for the next 10 minutes or so. All right, so you are asked to solve. All right, you're asked to solve. I want to do one that has everything in it, right? So you're asked to solve 3x minus 2 over 4 equals 12 minus 5x, something like that, right? This equation has everything in it. It's a fraction, it has addition in it, it has subtraction in it, it has everything, all right? Now, in order for us to solve this equation, remember that the word solve implies that we need an actual value for the variable. And in this case here, the variable is x. So we're looking for what value of x will make this equation true on both sides. Golly, I think you have your cursor. I think it's moving across the screen. Sash Monique as well. I can see your cursor moving. All right, that's fine. All right, good. So we have 3x minus 2 divided by 4 is equal to 12 plus 5x, right? Now, remember that step number 1, when you look at the equation, you need to ensure that you remove whatever is preventing you from getting the variable. Okay, Sash. So you should move whatever is preventing you from getting the variable by itself. Now, pay very close attention to the fact that there are two equations. There are two variables here. There's one x here, and there's another x here. But before we can even get close to that, what we need to do here is remove the 4 that's underneath the variable here. We need to remove the 4. All right, so what we need here is that we're going to go ahead and we're going to say 4 multiplied by... Sahinia, what is happening? You cannot see? You cannot see what?
Sir, it's telling me that whiteboard's error occurred, so I'm not sure.
All right, so exit the class completely and then come back in.
Okay, sir.
All right. All right, so first thing that we need to do here is that we need to get rid of the 4 that's underneath the equation here. Once you see a variable, once you see something under the bottom of the equation, you need to get rid of the 4. And so because the 4 is under the bottom, it's division. The way to remove it is multiplication. So we're going to have 4, right, multiplied by 3x minus 2 over 4 is equal to 4. And we're going to open a bracket like that, 12 plus 5x, all right? Now,
Okay, sir, I'm seeing it now. Thank you.
That's good. All right, so you might be wondering, why did you use a times over here and then use a bracket over here? So I use a times over here because right away I know that I'll be able to cancel the 4 here. I know it's going to disappear when I multiply by 4. But why did I use a bracket over here? Because if I write down 4 times 12 plus 5x, what this means is 4 times 12, but it doesn't mean 4 times 5x. The 4 only multiplies the 12. It does imply that it should multiply the 5x. And so when you're writing it down, you have to know when to use a bracket versus when to use a multiplication sign. So in this case here, I use a bracket over here because the 4 must be used to multiply the 12 and the 5x. If you don't want to use a bracket, what you can do instead is you can say 4 multiplied by 12, and then you say 4 multiplied by 5x, right? You can do it that way if you want to. If you want to use a sign, like a multiplication sign, ensure that the 4 multiplies everything that's in the equation. When I cancel the 4's on the left, I'm going to end up with 3x minus 2. And then I have 4 times 12 is 48. And then I have 4 times 5x, that's 20x. All right, so I have a very straightforward linear equation now. Now I have a choice. I can bring the 3x over here, or I can bring the 20x over here. Either side you bring it, it's going to be the same answer, right? It's going to be the same end result. So for the purpose of making the equation simple, I'm just going to bring my 3x over here, right? And then once I bring my 3x over there, I'm going to bring the 48 back over here because I want the numbers on one side and I want the variables on the other side as well. Now, notice that I didn't touch the minus 2. So I'm going to write back my minus 2. And then I'm going to bring the 48 over to my left. I'm going to end up with negative 48 because it's negative. Sorry, it's positive, so I bring it over, it's negative. And then that's going to be equal to 20x, which I didn't touch. And I'm going to bring the positive 3x over. I'm going to get minus 3x. So negative 48, sorry, negative 2 minus 48 is negative 50. And that's going to be equal to 20x minus 3. That's going to be negative, that's going to be 17x. That's going to be 17x. So therefore, if I divide both sides by 17, I'm going to end up with x being equal to, well, in this case, the 17 is a prime number, 50 is an even number. So I'm just going to keep my answer as 50 over 17. I don't need to convert it to a decimal or a mixed fraction. So that's fine. So the answer is x equals 50 over 17. All right? So we just have to practice these things. When it comes to like an equation, we have to just practice them. And we can remember the rules and the steps to follow to solve them. Okay? All right, and then now we have an example. I wonder if I turn my screen like this, if you guys will be better. Are you guys seeing it better now, so you don't have to zoom? Is it better?
Sir, I don't think I got the end part of what you just did. Go again with the how you get the 17, please.
The 17 is beside the x. So the 17 and the x is married by multiplication. So you divide to split them.
Oh, me see now. Thanks.
All right. Is it better when I turn it this way, guys, or should I turn it back portrait way?
No, sir, it's I can hardly see now. I don't want to try and trouble the screen because there's a lot of stuff going on there.
All right, good. So that's it then. So there you go. All right. Lovely. All right. So that's how you solve that equation. And there's many types. As I said, if you don't practice these, if you don't practice them, get familiar with when do I carry over, when do I divide by, when do I multiply by, you're gonna, it's gonna be a little bit challenging for you. All right. But here we go. We're gonna do another one. We're gonna solve this inequality now. So this time now it's gonna say solve the inequality. So solve the inequality. And inequality is just, this is where now we're not using the equal sign, but we're using the inequality sign. The rules remains the same, not change. So let's say you end up with 4x minus 3 over 4 is less than or equal to 7x minus 2 over 5. Something like that, right? An equation like this. Now, once again, as you can see, there's different approaches to this. But what we want is an approach that's quite seamless. An approach that will make the process of getting to the answer easier. Now, I'm not telling you that the way that I'm showing you now is the only way. This is just the way that I prefer, and I find it, to me, I find it seamless. Meaning like I'm not gonna get into much hiccups or having to do extra stuff that I don't want to think about. When I take this approach towards solving it, I find that I get to my answer easier and faster. All right, that's just my opinion. But you guys are free to experiment and see what you guys like. Now, just like the previous example before, I told you that once there is a number or there are numbers at the bottom of the equation, meaning that there's a denominator involved, you need to get rid of those numbers. Now, in the first example, there was only the 4 that was at the bottom. But in the second example, there's not just a 4, but there's a 5 as well. So what's going to happen here is that it makes no sense I do one line to get rid of the 4 and then do another line to get rid of the 5. We're making the math problem that could be done in one line. We can do it. We can get rid of the 4 and the 5 at the same time. All right? So in this case here, if there was only a 4 that was at the bottom, I'll just multiply everybody by 4. Or there was a 5 at the bottom, I'll just multiply everybody by 5. So in this case here, I'm going to multiply everybody by 20. All right? So you get the 20. The 20 is the LCM of 4 and 5. So the 20 will cancel out the 4 and the 5 at the same time. So here's what we're going to do. All right? I'm going to grab my red ink here. Right? And here we go. So I'm going to have 20. I'm going to put a 20 everywhere before I put down everything else. So look at this now. I'm going to have a 20 here. I'm going to put a 20 here. I'm going to put a 20 here. Put my less than sign here. Whoops. So it's going to make sense shortly. All right. So I'm going to put a 20 here. I want to use the reading first. All right. I'm going to put a 20 out here as well. All right. I'm going to put a times here as well. Times here as well. Times here as well. And times here as well. Now watch this now. Watch the blocking now. The blocking now is going to tell us what we're going to put beside the 20. So the first 20 will multiply the 4x here. Let me just see if we can zoom up like a bit. All right. So the first 20 that I've written here, that first 20 is because I want to use it to multiply the 4x. So that 20 is going to be used to multiply the 4x. That's the first term there. Right. I'm going to put a minus between here. You know what? Let me just, hold on. I think I'm writing too fast. Let's take our time. The first 20 will be used to multiply the 4x. The second 20 will be used to multiply the 3 over 4. The third 20 is used to multiply the 7x. And the final 20 is used to multiply the 2 over 5. Sir, so why are you multiplying by 20 so much time? Remember, guys, an equation is like a scale. And if you tilt the scale on one side to keep the scale balanced, whatever you do on the left, you have to do it on the right. What you do to one term, you have to do it to all terms. So if I'm multiplying the 3 over 4 by 20 because I want to cancel the 4, I can't just affect one term and don't affect the others, right? So I'm going to multiply everybody by 20. So look what's going to happen now. The first 20 multiplies the 4x, and I'm going to end up with 80x. Now notice here that this 4 will be cancelled by the 20, and I'm going to be left with 5 at the top. And notice now, negative 5 times 3 is negative 15. Less than or equal to 20 times 7x is going to give us 140x. Right? And then notice that this 5 now is going to be cancelled by the 20. I'm going to be left with 4. 4 times 2 is going to give us 8. So in one line, I was able to cancel the 4 and the 5 at the same time. Now you have a choice here. I can choose to bring over the 140 over here. And I'm going to do that just to bring across a point. So I have a choice. I can bring over the 140 to my left. Or if I want to make life easier for myself, I'll bring over the 80 to the right. For the purpose of this example, and because it's the final example before I move on to the new topic, I'm going to bring the 140 to the left. I do recommend, though, that when you're transposing, try to transpose the numbers towards the sides of the bigger number. Dav, I think you have your cursor in this in the direction of where I'm writing. Dav, okay, thank you. All right, good. So now I have 80x. Let me write that properly here. Give me a sec. All right, good. 80x, I'm going to bring over the positive 140. I'm going to end up with 140. All right, and then I'm going to have less than or equal to, I didn't touch the negative 8. Notice, I didn't touch negative 8. All I did was just bring over the negative 15 to make it positive 15. Remember, the objective is to get the variables on one side and everything else on the other side. So 80x minus 140, mathematically, that's going to give me negative 60x. And that's less than or equal to negative 8 plus 15. That's going to give me positive 7. So in this case now, finally now, pay close attention to what's about to happen here. I'm going to go ahead, and because I want to separate the minus 60 away from the x, I'm going to go ahead and divide by negative 60. But watch what happens when I divide by a negative. I end up having to turn the sign the other way. Sir, why? That's the rule. In an inequality versus an equation, with an equation, no reversal takes place. With an inequality, if I divide by a negative, then the sign has to turn the other direction. So x then, as opposed to being less than or equal to the answer, it becomes greater than or equal to negative 7 over 60. All right, negative 7 over 60, 7 over negative 60, same result. All right, same difference. So instead of seeing 7 divided by negative 60, we'll just simply put a minus sign in the center and just say 7/68. So the answer is negative 7 divided by 60. All right. So that is basically how that solution is derived there. Okay. All right. So that's it. That's the idea. All right. So all we need now is just some practice consistently to see these equations. So remember, 4 main rules of equation, regardless. If there is a number that's attached to your variable by addition, you're going to bring it to the other side and change the sign. Right? When you go to college, if and when you go to college and you're learning math, they'll tell you that that's the worst thing that they don't like hearing, that bringing across to the other side. But, for at this level, we have to try help tell you what we need to tell you so you can understand. But in reality, what happens is that we are adding or subtracting from both sides. But when something is attached to your variable by addition, you bring it over, it changes to subtraction. If it's subtraction, you bring it over, it becomes addition. If something is tied to your variable by multiplication, you divide. And if something is dividing your expression or your variable, you're going to multiply each variable in the equation by that number or numbers. All right. And that's it. All right. So that's the foundation that we have set as it relates to equations. Just keep your eyes open because these things are going to be coming at us repetitively. All right. So that takes care of that topic. Now we have to move on to something new tonight. And so the topic of discussion in the next 45 minutes, we are hoping that we can achieve something tonight. Tonight's topic is going to be solving quadratic equations. All right. So head up that for me, guys.
Sir,
Yes, dear.
If the sign change only if it has equal or if it's
Only
greater
inequality.
than
Only inequality.
okay.
Only if it's that sign. Only if it's that sign. Inequality.
Only if it's the one with the thing underneath, or
Yes.
is it
Only with the only if it's this sign. Less than, greater than, less than or equal to, greater than or equal to.
okay.
Only those will reverse.
Okay.
Yeah. All right. Any other question before we move on, ladies and gentlemen? Because we're going to need this skill as we go into other types of equations, simultaneous equations, quadratic equations. We're going to need the skill. Any questions? All right. All right. So I'm zooming up and I'm zooming out that part of the screen. All right. So for tonight, we are going to be looking at quadratic equations. How do we solve a pair of quadratic equations? All right. So here we go. We're getting into that.
Excuse me, sir. What was the topic you said again?
Solving quadratic equations. And I also have a video on this already. For some of you guys who may have messaged me, I've not had my phone for a couple of days. I left it in a vehicle, right, with somebody. So I'm just waiting for the person to return my device. If you have messaged me and you think I haven't responded, it's because I have not had the phone for like 3 days. So as soon as I get it back, if you have messaged me, I will respond. Okay. All right. So solving quadratic equations. Now, in a previous lesson, we would have been exposed to the term quadratic, right? It's that AC method thing that we spoke about, right? You can review that recording. We spoke about an expression right before we started linear equations last week. We would have wrapped up the topic of quadratic expression, where we use that AC business there. And we're gonna review that tonight. But now we're gonna turn it into an equation. So we're gonna learn an additional step that's required. All right. So take down these notes for me. I'm gonna be dictating. It's a little difficult to write on the screen. So write down this information for me, guys. All right, good. So the here we go, guys. Information. The general form of a quadratic equation. The general form of a quadratic equation. The general form of a quadratic equation The general form of a quadratic equation is ax squared plus or minus bx plus or minus c. And I'm going to use my reading here because I want you guys to know that how important this is, equal to 0. I've placed that equal to 0 because this is what makes the difference between a quadratic expression and a quadratic equation. All right? The equation involves the equal sign and the expression does not involve the equal sign. But more important, it's not even about the equal sign, it's about what it's equal to. So for a quadratic equation to be, for an equation to be quadratic, the quadratic expression must be equated to 0. Now, just before you even think about asking, you may be wondering, is there a case, sir, where we might get an equation that's not equal to 0? Yes, it's very possible. And we're going to discuss that hopefully near to the end of the class. We'll look at an example that's not equal to 0 and how do we deal with that situation. All right. So the general form of a quadratic equation is, as you see it here on the screen, ax squared plus or minus bx plus or minus c. Specifically, it must be equal to 0. All right. Where, continuing information, where a, and I want to change this letter a here. Let me change this one. I don't want to use this type of a. I want to use this one. Oops, sorry. My apologies. I want to use this a, right. Where, continue, where a, b, and c are what we mathematicians call constant. Where a, b, and c are constants. All right. And in this context, the word constants meaning a numerical value. All right, where a, b, and c are constants. So basically what we're trying to say is this letter here, and this letter here will be replaced with numbers. All right, this will be replaced with numbers. It could be negative, it could be positive. We don't know what it's going to be, but when you get the equation, you'll know. All right, so where a, b, and c are constants, full stop. There are two methods. There's more than two, but for the scope of CXC, we're only using these two. So there are two methods that can be used to solve a quadratic equation. There are two methods that can be used to solve a quadratic equation. There are two methods that can be used to solve a quadratic equation. And I'm going to write them on the screen what the methods are. First method is called the factoring method. So the factoring method. All right, and then the second method is going to be called the quadratic formula. So it's called the quadratic formula. And I'm going to put right in bracket here another word beside quadratic formula. I'm going to put the word universal. In a moment, you'll understand what that means. All right. So the quadratic formula is universal. And I'm assuming that the context of which I've used the word universal, meaning that it's applicable all the time. So basically, given any quadratic equation, the quadratic formula is applicable all the time. So basically what I'm trying to say is then that there are limitations to this. So this factoring method has limitations, which I'm going to demonstrate shortly. So there are certain questions that us mathematicians say that it cannot be solved by factoring because the expression is not factorable. All right. So if you get an equation that's not factorable, you're going to see what I mean by that shortly. If you get an equation that's not factorable, then the factoring method cannot be applied. But if it's not factorable, it doesn't mean that you can't use the formula. That's why the formula is universal. So the formula, you can use it all the time, but the factoring method is limited to certain types of questions. All right? And in the next 40 minutes, you will understand what we're talking about. All right. Now, because we have already gone through the process of factorizing, and we have been exposed to how to factorize a quadratic expression, the only addition to that technique will be the last bit that we have at the bottom that you're going to be learning tonight. All right, so I'm going to take a question. I'm going to show you how it is that we use the factoring method to solve this question. All right, so here we go. All right, I remember that a quadratic equation is not the same thing as a linear equation. The equations that we were doing earlier, there's nothing in that approach that can be used to solve these types of equations. You can't carry over nothing and divide by nothing. Not like that can work. All right? So please ensure that you don't try anything no new funny stuff with this type of question. All right, so here we go. I'm going to go up here, zoom out. Hopefully you guys have the information. And then we're going to zoom right back up. All right, here we go. All right, here we go. Good. All right. So the instruction is going to say, solve the equation below. That's all it's going to say. It's not going to say solve the linear equation, solve the quadratic equation. It might say solve the pair of simultaneous equation. But for sure, me know them not going to use the word quadratic on you. They're going to expect you to know what the quadratic equation looks like. So solve the equation below. And here's the equation. So the equation is going to be 2x squared plus, what should I say now? What should I say? 2x squared plus 7x plus 5. Yes, equals 0. So we should solve that equation. All right? So solve the equation 2x squared plus 7x plus 5. You might ask, sir, so you've taught us two equations already. You've taught us linear, and you are now teaching us quadratic. How do we know the difference between the two? And how do we know that the approach you're about to teach us isn't the approach that we should use with the previous question? If you notice that none of the equations I gave you last week, along with the ones that were worked out in the beginning of this class, never had a square. Did you realize that? None of the ones that I gave you before had a square. All of them simply had an X or a Y or an A or a B or just a single letter. But this particular equation here, it has a very distinct look to it. And that distinct look, if you pay very close attention right here, it has a square there. And that's what makes it quadratic. Now, let's take the factoring approach to it. We're going to go ahead and apply what we learned in the last 2 weeks ago. 2 weeks ago, I believe we would have learned something like this. Please help me if you remember it. 2 times 5. And that's going to give us 10. And we discussed that we're going to break up the 10 into pairs of factors. So we know that the pairs of factors for 10 is 1 and 10. And 2 and 5. And at this stage, we need to make a decision as to which one can produce the middle. We need to decide if it's this one or if it's that one. We need to choose the one that if we add it or we subtract it, it might give us the middle number. And if you're paying very close attention, you'll realize that 2 and 5 is our selected factor. Because if I make 2 plus and I make 2 plus again, plus 2 plus 5 is going to give us plus 7. And if I multiply positive 2 times for this positive 5, I will get positive 10. So my selected factor is going to be 2 and 5. Now, if I then go ahead now and I keep my 2x squared, I'm going to remove this 7x from here. I'm going to replace that 7x with plus 2x plus 5x. And I'm going to bring back down my plus 5. I'm going to set it equal to 0. All right? For those who are seeing this for the first time, that recording has already zoomed it up. What do you mean by that? All right, hold on. Let me see if I can. Is that better for you? Is that better? I think you may have to come up, exit the class and come back in the class, Miss Grayson. Because I'm zooming up the screen and I'm seeing it big and bold. So you might have to exit the class and come back in. All right, here we go. So 2x squared plus 2x plus 5x plus 5 equals 0. Now, boom, go ahead, put these into groups of 2. And we're going to factorize. So here, you can see that the repeated factor is 2x. And then 2x divides into 2x squared will leave us with a single x here. And 2x into itself will go one time. If you divide something into it, so if you divide 2x into itself, you're going to get one time. Now over here, you'll realize that the common factor here is 5. And 5 into 5x goes x times. Because 5 cancels 5, leave us with x, and 5 into 5 goes one time. So we end up with 2 common factors in the bracket, which everything you're seeing here is not unfamiliar, because we would have gone through a series of examples with these. So the common factor is going to be x plus 1. All right, Ms. Grayson, that's good. It's x plus 1, and the bracket is going to be 2x plus 5. But most importantly, guess what we leave off? The equal 0. Don't forget the equal 0. Now, 2 weeks ago, had we gotten to this stage, we would have been finished, because the instruction 2 weeks ago was not solved. The instruction 2 weeks ago was factorize the expression. 2 weeks later, we are now solving the equation. Guys, please keep your mics on mute. Thank you. Angelica, your mic is unmuted, Miss Angelica.
I'm hiding. Put your far.
Stash Monique, your mic is unmuted there. All right, good. So 2 weeks ago, as I said, guys, there wouldn't have been an equal 0 attached to this. 2 weeks later, we are now looking at an equation like this now where it's equal to 0. So how do we proceed from here? How do we move to the next step? We move to the next step by simply taking the x plus 1 and equating it to 0. And then we're going to also take the 2x plus 5 and also equating that one to 0. So at this stage, what we do is that we take each bracket and solve each bracket separately, individually. Solve them as separate equations. And if you notice that once we take them out of the bracket and set them separately, we end up back with equations that's related to where we're coming from last class. And you can see here that if I bring over the 1 to that side, I'm going to get x is equal to -1. And if I go ahead now and I bring this 5 over here, I'm going to end up with 2x, which is equal to -5. And if I go ahead and divide this side by 2 and divide this side by 2, I end up with a final answer of x is equal to -5/2. So what we end up with here is 2 solutions. X is equal to -1 and x is equal to -5/2. And those are what we call the solutions to the quadratic equation. All right. So from everything from here, we would have gone through in its entirety in the last class. So it is just this last part down here, so where we take the brackets that we have gotten or that we have arrived at and set each bracket separately equal to 0 and solve. And that's the only addition that we're learning tonight. All right. So that's just how you deal with that part. So once I say solve the equation, then you get down to that section, separate the brackets equated to 0, and solve the brackets separately. Now, we're going to take this very same question, right? We don't want to use a new question. We're going to take this question now, and what we're going to do is that we're going to solve it using what is known as the quadratic formula. We're going to solve it using the quadratic formula. And so you might ask, sir, why is it that since as we already know to do this, why can't we just go ahead and stick with one method? All right, let us solve it first, and I'm going to show you why we have to learn the quadratic formula. Now, I'm not sure how much of a good news this is, but a lot of the times I tell students, the formula is on the paper, the formula is on the paper. And when I tell them that the formula is on the paper, I'll give them the formula and I'll tell them that this formula solves this question, and them still get it wrong. So I don't know if telling you that the formula is given to you on the exam paper is going to help you, but yes, the quadratic formula is written on your exam paper in the formula section. So once again, your only task will be to know when to use it. Assuming that you guys have seen this formula before, give me a sec, let me just grab it. Assuming that you guys have seen this formula before, it is called the quadratic formula, x equals minus b plus or minus the square root of b squared minus 4ac all divided by 2a. All right? Not the prettiest of formula, right? Because it looks very complicated to remember. And it can be. If you're trying to study it, it might take you a while. But again, you don't really have to study this thing. You just have to remember when and where to use it. So when you use it is when you want to solve a quadratic equation. And where is when. So in this case, when you use this formula is when you want to solve a quadratic equation. All right, so let us examine the formula and see what's going on with this thing here. Let's grab a different color ink and try to examine some things. Now, if you notice here, ladies and gentlemen, that this particular formula, it has some variables, right? We have a b here, we have a here, we have another b right here, we have another a right here, and we have a c here. So there's no way you can solve an equation that consists of a wide variety of variables, letters. So to solve this, we need to replace those letters with numbers. Let's grab our equation. We're going to use about the same equation. We're trying to get back the same answer here and here. All right? So let's grab the equation. The equation that we solved earlier was 2x squared. Sorry, my apologies, guys. So the equation that we grabbed earlier was 2x squared. Where is it? Okay, give me a sec. So it's 2x squared plus 5x, or was it plus 7x?
Sorry, it was plus 7x.
Thank you. So it's plus 7x. Thank you, Zahenia. So it's 7x. Disappeared. And then we're going to add plus 5 equals 0. So same equation we're solving. All right? And so we're going to get the same answer. But I'm going to show you how we get the same answer now. Now, before we can actually go ahead and solve this, let us first figure out how would we get the values of a, b, and c. Now, to get the values of a, b, and c, we have to pay attention to the numbers that appear before the variable. And if you compare this equation carefully, here, I'm going to write something here. If you compare and contrast both equations, ax squared plus or minus bx plus or minus c. Compare and contrast, guys. Look at this. Do you notice here that there's an a that's in front of the x squared? Right here, there's an a in front of the x squared. Yeah, there's an a in front of the x squared. And guess which number is in front of the x squared here? So 2. So right away, by comparing, because there's an a in front of the x squared, and if you look at the actual equation, there's a 2 in front of the x squared, it is safe to say that a is equal to 2. If you look carefully now, and you see that there's a b that's in front of the x, And if you notice that there's a b in front, there's a 7 in front of that x. Now you can clearly say that b is equal to 7, right, by comparison. And if you notice that this term here, c, is a constant. It's a constant by itself. It's just standing out there by itself. So c is all out there by itself. 5 is all the way out there by itself. It is safe to say that c is 5. So it's very so to replace the values of a, b, and c that are in the formula, the values of a, b, and c are simply the numbers that appear in front of the variables in front of the equation. So let me just undo all of those there, right? And we're going to undo this as well. That was just for comparison's sake. We're going to go ahead then and we're going to say then that a in this case is equal to 2, b is equal to 7, and c is equal to 5. All right? And so we're going to use a substitution technique. We are going to go ahead and replace the letters. All right, let me just zoom out here and get it a bit closer. All right. Okay, here we go. All right, good. So now what we're going to do here is that we're going to go ahead and we're going to replace each of these letters with the numbers that we have chosen here based on the equation that's given. All right. And if you're wondering if they're going to always give you the equation, guys, them have to. How are you going to solve? What equation are you going to solve if they don't give you the equation? So let's go ahead and replace the letters. We're going to place these numbers respectively, right here and here and here, in the respective position. So we're going to go ahead and we're going to say x is equal to negative b is 7, because it's negative b right here. So it's negative 7 plus or minus the square root of b again, but this time b is squared, so negative 7 will be squared, minus 4 times a value, which we've chosen to be 2, and the c value, which we have chosen to be 5. And everything now will be all over 2 times the value of a, which is again going to be 2. All right? So we're going to work this out like our basic arithmetic problem. X is equal to, nothing outside to work out, so that's just negative 7, plus or minus. We're going to go underneath the square root now. And we're going to find out what's the result of what is under there. All right? So we're going to go ahead then and we're going to say negative 7 plus or minus the square root of. When you square negative 7, we're going to get positive 49. All right? And don't let the calculator fool you, Remember that every time you square something, it doesn't matter what you're squaring. You see, once you raise the number to a power of 2, it is positive. Now, in case some of you type in negative 7 squared and you're getting 49 and you're confused as to why sir is writing down 49 and the calculator is telling me 49, it's because you leave off the brackets. So that's why I'm telling you that even when you square a negative number, it has to be positive. All right? So this requires you to square the negative and the 7 at the same time. So that's 49. Minus now, right? 4 times 2 is 8. 8 times 5 is 40. So 4 times 2 is 8. 8 times 5 is 40. And that will be all over 2 times 2, which is 4. All right? Let's continue to break it down. X is equal to negative 7 plus or minus. If you take 40 from 49, you realize that you end up with the square root of 9. And that's equal to, that's all over 4. All right, that's all over 4. And so x is equal to negative 7 plus or minus, and if you take the square root of 9, you'll find out that you get 3. And that's all over 4. So within a couple of lines, quick, the complicated equation that you saw at the top, formula, chop down to just minus 7 plus or minus 3 over 4. Now, here we have a situation, or quite an unusual situation, where we end up with this plus or minus business. How do we sort out that? To sort that out, we're going to go ahead and do a split. We're going to do a split. So we have two answers. X will be equal, pay close attention to what's going to happen here, guys. X will be equal to, so X will either be equal to negative 7 plus 3 over 4, or x will be equal to negative 7 minus 3 over 4. So we do a little split. So just as how we got 2 answers when we did the factoring method, we're going to get 2 answers when we do the quadratic formula as well. So in this case then, if you work it out, negative 7 plus 3 will work out to be negative 4 over 4. Or on the other side, minus 7 minus 3 will work out that x is equal to negative 10 over 4. And if you break it down here, you end up with x being equal to negative 1. Or when you break it down here, 2 into 4 goes 2 times, 2 into 10 goes 5. X works out to be negative 5 over 2. All right. I know what you say. I know exactly what you're saying in your mind now. You say, then, sir, I have to go through that little long method to get the 2 answers. As I said to you earlier, guys, each method has its respective approach. Sorry. So each method has its respective approach, right? Because there are some questions that, as I said, there are some questions that you are not able to use the factoring formula. So you have to use the quadratic formula. Let me see if I can I apply this? Oh Lord, I don't know how to use this thing here. Oh Lord, that's not working. All right, so anyways, Miss will learn how to do it. All right, so you can see that we get the same answers using 2 different approaches. So now you're going to see we have 15 minutes, well, 17 minutes, guys. So earlier, I would have said to you that the quadratic formula is universal and the factoring method is limited. There's limitations to it. So I'm going to give you another example now where if you are the type of student that prefers the factoring method, and I usually find that a lot of students don't really prefer the factoring method. If you're the type of student that gravitates towards this method more than this method, because here's the excuse that I hear year after year after year. Sir, method 2 too long. But then other persons say method 1 short, but it still confused them because, obviously factorization isn't anybody's favorite topic. So they're obviously going to gravitate towards method 2 because it's more arithmetically written. But there are person that, them find when the maths is too long, it confuse them. So they want one shorter method. So your choice is going to your choice is going to be relative based on you and how you feel. All right. But here's an example now, right? Where we are going to try to use the factoring method, and you're going to find that you're going to end up stuck. Like you can't move forward, right? And so when you end up with a situation like this where you're trying to solve the equation and it's not factorable, then your only choice is going to have to be using the quadratic formula. So here's an example that I'm going to give to you now. All right, I'm zooming up, guys. All right, so here's an example. All right, so remember that the instruction is going to be very vague, So the instruction is going to simply be this. Solve the equation. It not gonna say nothing. I'm going to give you a little clue though. There's a little thing that they do to kind of give you a hint. All right, so solve the equation. And here's the equation that they're going to give you. They're going to say, solve the equation x squared plus x minus, let me see here. Can this work? Yeah. All right, that's one, right. So I'm giving you a simple one, right? We're not trying to make the class too difficult. So here's an equation. You have to solve the equation x squared plus x minus 4 equals 0. All right? Now, when you see this, right, what you're going to see is, oh, yes, remember Mr. Pierre wrote this in a class, man. We know if we solve this, a factorization. And here's what you're going to quickly do. You're going to quickly do this, right? I'm hoping that you don't, but you're going to quickly do this. All right, remember Mr. Pierre do this. He says that we should go A times C, and then that is 1 times negative 4. And then you will get negative 4, and you'll be like, all right, yes, I'm good now. You draw your line, and you say 1 times 4 All right, 2 times 2, and what you know? You try to get back 1. So now you start scratch your head and you're going to say math's hard now. You're going to say math's hard. Nicolita, I think your mic is unmuted there. All right, thank you. So you're going to say now, oh, Lord Jesus, I'm stuck. Because you remember when I also said that you have to choose one of these? You have to choose one of them because one of them is going to give you back the middle term. But you're looking at this and you say, but hold on. But a 1 there, so 1 from 4 is 3. 1 plus 4 is 5, so that can't work. 2 plus 2 is 4. And 2 from 2 is 0. That can't work. And then you realize that 4 is a small number. You don't have no more factors. So this expression here that you're looking at is an expression that it can be solved, but it cannot be solved by factorizing. So we see that this is a non-factorable equation. So it's a non-factorable equation. You can't use the factoring method to get to your answer. Even though the factoring method is shorter, this is non-factorable. Non-factorable. And if it's non-factorable, then that means you don't have a choice. You must use the quadratic formula. All right? You must use the quadratic formula. So here's the quadratic formula then, guys. All right? Here's the quadratic formula. I'm going to go up here, and that's going to be the quadratic formula up here. So here it is. So this time now we don't have much choice. We don't have no choice at all. Not much choice. We don't have no choice at all. So we're going to have x equals, why am I writing with red? Mr. Peart. So here we go. So x equals minus b plus or minus the square root of b squared minus 4ac all divided by 2a. All right? And so x is going to be equal to, no, hold on, before we do that, we need to get the values of a, b, and c and make sure so we don't make any mistake. Can anybody tell me what is the value of a? Based on what we have discussed so far.
1.
A is equal to 1 because there's no number in front of the x squared, so it's up 1. What's the value of b?
1.
1.
1 again. Make sure you pay attention to the sign in the future. And what is c equal to?
Minus 4.
Negative 4. Very good. All right. So now that we have those values, then thank you so much for your participation. We're going to go ahead and we're going to say x is equal to. So x is equal to negative b, which is negative 1, plus or minus the square root of 1 squared minus 4 times a is 1 times c is negative 4, and everything is going to be all over 2 times 1. All right? Just chop this down quick and fast. So x will be equal to negative 1 plus or minus. We're going to work out what is underneath the root sign. 1 squared is 1. And watch it now, guys. Watch this now. It's that, let me grab my marker. It's the negative here with a negative here. I multiply. Watch out. That's a quick little trick. Right? You have to look out for that little trick here. Because in the previous example, you notice that I just brought down the minus sign. But watch this now. This one becomes plus. So you have to watch out when the signs are going to clash as well. So keep your eyes open for that. And 4 times 1 is 4. And 4 times 4 is 16. All right? So we end up with 16 here. So now, before I actually go ahead and show you what you're going to happen now, ladies and gentlemen. Let's say you're working the problem and you're not really paying attention, or the nerves get to you and you're going to write down 1 minus 16. Can you go ahead, guys, and type in your calculator for me and confirm what is the square root of 1 minus 16? Tell me what you get on your calculator when you take the square root of the result of 1 minus 16.
Minus 15.
Right, so what's the square root of minus 15?
No.
What did you get? What did you
Square
get
root
there?
of
Minus
minus
15. Yeah,
It does show me error.
Let me-
Something alright.
good. You're going to get an error, which is exactly the reason
Yeah,
why
it doesn't
when you,
not come up.
not now come up. So that, the reason why you're getting that is because you cannot find the square root of a negative number. That doesn't exist at this level. It exists, but it exists at a higher level in mathematics. It's called complex numbers. So at this stage here, you're not going to get a question. So this here is an error that is made commonly by mathematics students at this level, where sometimes they are missing these two arrows that I have here, those two signs. If you make a mistake like that, it means that you made an error right in this line right here. So, whoops, sorry, in this line right here, you made an error right there. So this is supposed to be a plus, right? And then this is going to be all over 2 times 1, which is 2. All right, so you have to look out for that because student will be working the question and they're very confident and then they see the error. So what they do, instead of writing minus 15, they just say, you know what, I mistake the calculator, make others write 15 instead and go on with them business. And that's incorrect.
Sir,
Yes, go ahead.
before you go much further, I have a question.
Lovely. I love to hear.
So you see, in the line above where you have the -1 plus minus square root of 1 squared, right after you did the substitution, I realized that for this equation, when you substitute it, the outside one is negative because that's what the equation said that we're supposed to do. However,
Right.
in the example that was given before,
Right.
when we're using the 2x squared plus 7x plus 5 in that one, I realized that you had made the negative, the 7 right, yes, the 7 right next to the square root.
Yeah.
Right here, it became negative. So what's the reason why that one was negative?
Well, the formula says, all right, so if you look at the formula, I know what you're asking me. All right, it's a very good question. Remember the formula says negative b, no? So negative will go in front of whatever value b is, and b is a positive 7. So if you take a positive number and put it right in front of a minus sign, it'll make the whole thing minus.
Right.
So it's minus 7. So because b up here was positive 7 and it landed in front of a minus sign, it became minus 7. Down here, whoops, okay, all right. So down here now, you realize that also b is a positive 1. It's a positive 1.
Yes, sir.
And it lands right in front of another minus sign, so it becomes minus 1. Hopefully that's what you're asking me.
Yes, sir. That's what I was trying to clarify.
Okay, I got you. All right. So if the middle number right here, so was a so watch this down. Very good observation, right? If this number, hypothetically speaking, if you get a math, like I give you a practice question or whatever, and let's say that this number was -1, then when this -1 lands in front of the minus that was at the b, then those two minuses are going to clash and become a positive 1 instead. All right. So bear in mind that this negative is already in the formula. So whatever b is, when b lands right there, there might be a clash. In this case, there wasn't a clash because the b value here was simply a positive 1. And because it got land right in front of the minus sign that is already in front of the b in the formula, it became a -1. Hopefully that gives you some clarity.
Yes, sir. I think that the explanation sense, I think I just need to do some practice to be comfortable with it.
Yeah, man, that's all I need. A couple of practice. All right, so 1 plus 16, guys, is now 17. We're running out of time. So 1 plus or -1 plus or minus the square root of 17, all divided by 2. All right. So now x is equal to -1. And you can go on your calculator now, guys. You're going to get a decimal. What's the square root of 17? Should be 4.0 something. 4.01, 4.02, something like that. Square root of 17. Help me, guys. Help me. What is square root of
Yes,
17?
sir. It's 4.1 or 2.
4.1. 4.1 rounded off, right?
Yes. It's
4.1.
4.123 and
Yeah, man, that's fine.
continue.
4.1 is fine. All divided by 2. All right. So in this case, now you're getting a decimal value as opposed to a whole number. So again, we're going to do a split here. X is equal to -1 plus 4.1 over 2, or x is equal to -1 minus 4.1 over 2. All right, go ahead, work out the top, press equal, and then divide by 2. Do not do everything all at once. -1 plus 4.1, then press equal and then divide by 2. You should end up with 1.62. Confirm, please. Or 1.52.
See 1.55.
I'm sorry, 1 point how much?
5.
I'm seeing.
I'm so sorry, I'm not hearing you.
1.5.
Her mic is going out and in there. 1.5 flat, 1.52.
Sir, I got 1.55.
Oh, 1.55.
1.05.
Yeah, Anthony, your mic is going in and out there. So that's why I'm not hearing you. All right, thank you. All right, and on the other side now, what is -1 minus 4.1? I think you should get minus 2.55. Confirm, please.
It's 3 again, 7.
3?
Yeah.
Try
I
again.
showed it right, but it's
Come on,
3.5.
try again. Something off. -1 minus 4.1 is minus 5.1. And when I divide that by 2, my math is telling me that that's minus 2.55. Yeah, man.
Yes,
Negative 2.5.
2.55.
Yeah, man. All right. All right, so remember, guys, if you're getting another number, remember you can't put everything on the calculator at once. You put in the top, press equal, and then you press divide by 2. So that's why you may be getting an answer, say something about 3 or whatever. All right, so these are your solutions here. All right, now I'm going to share a couple. So I'm going to take 5 extra minutes out of your time, right? Because I want to make sure that this is clear, right? Because
Sir, can you pull down the screen a little so I can?
There it is. Oops.
So,
sorry. So there it is. Hope you can see it there. All right. So I want to share something with you because there's a couple tricks that you need to be mindful about. I know that some of you guys are a little bit industrious, so you will go search for questions, and I want to prepare you for what you might see out there. There's a few things that I want you to keep lookout for. Now, we've learned a lot tonight, right? We've learned a lot, right? And so one of the things that I want to share with you is Csec does something on the paper that will make you know exactly when they want you to use the formula, right? Right? When it's factorable, you'll know. It's when it's not factorable, you'll know. There's a little thing that they write, right? And a lot of teachers, when they're teaching it, they don't mention it. I'm not sure if they don't know it or they don't realize it. That's the thing. But Csec will do this to you. I'm going to zoom up shortly here. Whenever it is that Csec wants you to use the formula, when them know that the formula is required and them know it not factorable, this is the cheeky little thing that they do. Watch this. What they do is that they'll say solve the equation, and watch what them do now. Them go so boom. 2 decimal place. Right there so. So when them attach on that little something with 2 decimal place, that's little something right there so is what make you know say you know if you better try factorize it because it's not factorable. It's when them start mention something about decimal place, no say it's not factorable. You say they don't mention it, like what I did up here. When I did mention it up here, it can be anyhow it's not factorable, you're going to see that to 2 decimal place or to 1 decimal place attached onto it. You say if it's factorable, they're just gonna say solve the equation. They're gonna say solve the equation and leave it up to you to decide which method you prefer. All right. So I wanted to point that out as well. All right. And there is another thing as well that I want to point out just in case you guys go there and you go find some little, them have a tendency now, right, where they rearrange the equation and try to throw you off. So what you are going now? I'm going to give you an equation. I'm going to give you a quadratic equation, and then I want you to tell me what is A, B, and C. All right, so I'm going to call these lookouts. Okay, so be aware. Be aware of these little things that they'll throw at you. Be aware. So be aware of these little tricks, right? Solve the equation. Based on how I teach you, you guys will know it's a quadratic, But watch them. Watch them carefully. Solve the equation. Four x minus 3x squared. 4x minus 3x squared plus 2. Can you tell me what is a, please?
3x squared.
Well, we don't remember say a can't be a letter,
Oh,
It has to
3.
be a number. So what is a?
3.
Check again. Look good.
It would be 4.
No. Try again.
It's minus 3.
Correct. Minus 3. So in here, just barely miss. So a is minus 3. Now I have 24 persons in the class and probably 20 or 18% be like, huh? What? What you mean a at 3? The examples you showed us earlier, Mr. Peart, a is always at the front. Notice Mr. Peart did not say a is always at the front. I said a is in front of x squared. So they have a tendency, what they'll do is that they will rearrange the equation. Hold on, let me set it equal to 0. They'll rearrange the equation and try and throw you off. Pay attention. A is in front of the square. B is in front of the x. And C is the constant. So don't bother watch them when they rearrange the equation. You know what they do? When they rearrange it, you rearrange it back. So you know what you do? You just take this now, and you say, all right, I'm thinking I can trick me. 3x squared plus 4x plus 2. Don't make them trick you. It's the same equation. They just place it at a different position. So be aware of this, all right? Keep your eyes out for that. Another thing that I want you to keep your eyes out for, because I know the class time is up, but another thing that I want to keep your eyes out for is this one. Watch this one now. Same instructions. Solve the equation. Solve the equation. 5x squared minus 8 plus 6x equal 12 minus 5x. And that's a quadratic. It's a quadratic equation simply because there's a square right here. So that's what makes it quadratic. So can you tell me what is A?
A is 5.
Correct. Very good. Can you tell me what is B?
Plus 6.
Incorrect.
11.
Correct. Who said that?
Dominic, sir.
Very good. Dominic, very good. B is 11. Sir, what? How you get 11? I'm not seeing 11 there.
Oh,
Remember
and then
that the
the x's.
quadratic must be equal to 0. So you can't have anything on the right side. So you have to go ahead and bring this over here. You have to bring this over here. And when you bring it over there, that's how the equation comes in place now. When you bring this negative 5 over there, it becomes positive 5x. And when you add the 5x to 6x, you're going to get 11x. So therefore, B is 11. What is C?
Negative 20.
B is negative 20. How did you get that? Because the 12 not supposed to be on the right side. In fact, nothing not supposed to be over here, so. Nothing nothing over here, so. Because from the get-go and the start of the class, we said that all quadratic equation, let me carry it up back up here, so, right? Remember when we just start, what we said, what we said earlier was that all quadratic equation must be equal to what? 0. That's what we said. So you say if it's not equal to 0, your task is to make it equal to 0 by ensuring that nothing is on the right. So in this case here, you're going to bring over the negative 12, sorry, the positive 12 over here. And so minus 8 minus 12 is going to give us a C value of negative 20. All right? So that is how those are the things you need to be aware of. But we will explore these as you see me more. Guys, for the Sunday classes, due to circumstances on my side, I won't be able to keep any more Sunday classes. The populations are a bit low, and I also have extra responsibilities that I will have to do that. So if you guys wish to come to any extra sessions, you'd have to come to the ones on Saturday, and that's the only one I have available. Okay. So if you want to attend, just come to the ones face to face. Otherwise, then we just have to go and make use of the ones that we do in the week. All right. But that is the end of it for tonight. If you require a video, I'm gonna send Miss Gentles because she's gonna communicate with you guys on behalf of me. I'm gonna send her the video link that will take you guys to a more structured short form version of this session, right? It's not a class, it's more like a small video that explains the quadratic equation. And if you guys would like a rerun of this, you can always watch that video and put yourself into a position. So that is the second to last topic in algebra. Next week when we come, we will be attacking.
Sir, can you zoom down
a
little, please?
Next week, Wednesday, when we come, we will be looking at we'll be doing one more recap question, and then we're going to look at, when we find these values, what are we actually looking at? And then we're going to be solving some simultaneous equations. And
Thank you.
next week will be the last class for algebra, right? And then we're going to move on to something new. All right? All right. With that said, have a pleasant rest of night and a good evening. See you guys on Wednesday. Good night.
Sir.
Thank you, and same to you, sir.
Good night, sir.
Good night.
Good night.
Good night,
Yes,
everyone.
go ahead, Latisha.
Nisha, question. Did
Go ahead.
you say the Sunday classes, whether face to face or online, is cancelled?
Yeah, the online is no longer existent, but I have some other projects that I have to deal with.
No, you have Sunday face to face?
No. Sunday was online. No Sunday face to face. No Sunday at all.
Okay, just Saturdays.
Yeah. For now.
Okay.
All right. Sashmanik, yeah, man, you can come. I haven't looked at it yet in Sashmanik, but you can come still and we sit down and we look at it. All right, guys. Have a good night.
You too.